Welcome Algebra 1 students to another Regents review video. This is the Algebra 1 Common Core January 2017 Regents exam. These are going to be the solutions for Part 1, questions 13 through 24 of this examination. Let's talk about a few things before we begin. If you are here to use my answers for cheating purposes, please refrain from doing so. You actually have to try the problems to master mathematics. Pretty simple. If you're here to check your answers, or if you were here to get a little bit of guidance, you've come to the right place. Hit that subscribe button down below and make sure that you visit my website at www.nysmathreadersprep.com. And just a reminder that I use a TI Inspire CX that can be purchased on Amazon. The link is on my website. So if you want this calculator, by all means go ahead and purchase it because it is quite a powerful tool. Without further ado, let's jump right into these questions. Question number 13. Here we go. All right, so it says, what type of relationship exists between the number of pages printed on a printer and the amount of ink used by that printer? So what I'm going to do is I'm just going to draw a quick sketch of maybe a little graph to the right. And I'm going to say the x-axis is pages printed, and I'm going to say the y-axis is going to be ink used. Well, as the number of pages that you use increases, the ink that you're using also increases. So it might look something like this. It is definitely a positive correlation because the amount of pages that you're printing and the ink used, they're both going up. A common misconception that people have is they say that it's going down. For example, some people don't call this ink used, they call it ink levels. And they may say, no, the more pages you print, the ink levels decrease. Be careful, that's not what it's asking you. It's asking you the amount of ink used. So just some people make that common mistake, and they say negative correlation, but it's not a negative correlation. It's a positive correlation, and it's causal. Many people say casual, but that says causal. Causal means that one causes the other. The pages printed causes the ink to be used. So that's why it is going to be choice 2 for number 13. All right, moving on, number 14. A computer application generates a sequence of musical notes using the function f of n equals 6 times 16 raised to the n power, where n is the number of the notes in the sequence and f of n is the note frequency in hertz. Which function will generate the same note sequence as f of n? So basically what you need to do is you need to match one of these, okay? 6 times 16 raised to the n power. This is actually the same thing as saying 6 times 2 raised to the 4n power, and I'll tell you why. The 16 that you see here, 16 can be rewritten as 2 raised to the 4th power. Okay? So I just have 6 times 2 to the 4th power raised to the n power. And that is equal to 6 times 2 raised to the 4n. The reason why this right here, ladies and gentlemen, is a power-to-power rule. So these could be multiplied together. So it's really 6 times 2 raised to the 4n. That is the same thing as 6 times 2 raised to the 4n. So your answer is going to be choice 2. Now, let's just say that you didn't know that. Graph this. Graph all your answers. I'll be happy to graph it right now for you. So let's go ahead and graph the original 6 times 16 raised to the x power. And let's graph 6 times 2 raised to the 4x power. And as you can see, it is the identical graph. It lies directly on top of each other. So therefore, the answer is choice 2. All right, moving on. Question 15. Which value of x is a solution to the equation 13 minus 36x squared equals negative 12? So how do we do this? Well, let's see, 13 minus 36x squared equals negative 12. So the first thing that I'm going to do is I'm going to subtract the 13 on both sides, okay? We get negative 36x squared is equal to negative 25. Okay, now we need to solve for x. So we're going to divide by negative 36 on both sides, okay? From here, we get x squared is equal to, now let's see, negative 25 divided by 36. That is going to be positive 25 over 36, okay? Now we take the square root of that fraction, which x is equal to plus or minus The square root of 25 is 5. The square root of 36 is 6. So your answer is x is equal to plus minus 5 over 6. And the only answer that works is going to be choice 4. That is equal to negative 5 over 6. And that's how you do number 15. All right. Pretty good so far. Moving on. 16. Which point is a solution to the system below? So the best thing to do is just graph this on your calculator. The first thing, actually before we do that, we need to convert this into y equals mx plus b form. So we're going to divide everything by 2. When you divide everything by 2, we get y is less than negative 6x plus 2. Okay, so that's what we're going to be graphing. Go to your calculator. Go to your graph, press the delete button, and it will come up as this menu right here. So click on less than, so less than. Y is less than negative 6x plus 2. Press your down arrow. And then do it again. So we get y, control equal, get a less than sign right there, negative 6x plus 4. Enter. Okay, so the solution is in this shaded region. Notice how the lines are parallel to each other. They never touch. And they're dotted, by the way. So if you're trying to find a solution that is either on the blue or on the red, do not pick those answers. It's not on the blue or the red. It has to be somewhere in the solution set. So let's look at our answer choices. 1, 1/2. Okay, well, 1 and 1/2. If I were to do menu, view, grid, line grid, 1 and 1/2, that's right here outside of the solution set. That makes absolutely no sense. Okay, so get rid of that answer. Choice 2, this is saying 0, 6. 0, 1, 2, 3, 4, 5, 6. That's all the way up here. That lies outside of the solution set, definitely. So that can't be the answer. Then we get negative 1/2, comma 5. Negative 1/2, comma 5. 1, 2, 3, 4, 5. Ladies and gentlemen, that does intersect the blue line. It is on the blue line, but it's dotted, so that's not a solution because it doesn't satisfy that inequality. So your answer is going to be choice 4, negative 3, comma 2. And if I were to show you using menu, geometry, points and lines, point, negative 3, 2. That, ladies and gentlemen, is the point right there in the black that you see hovering right over there. That perfectly lies in the solution set. All right, that's number 16. Moving on to 17. All right, so it says here, when the function f of x is equal to x squared is multiplied by the value a, where a is greater than 1, the graph of the new function, g of x equals a x squared, is what? So when a is greater than 1, it has a couple effects. First of all, it's positive, so therefore the parabola opens upward. Okay? And if it's greater than 1, it is going to be a narrow graph because it's dilating it by a scale factor that's greater than 1. It's going to shrink or get more narrow. So your answer is going to be choice 2, opens upward and is narrower. Because if you graph x squared, let's say you just want to graph x squared, and then you graph, let's just say you want to make it 2x squared. As you can see, it's still upward and it's a little bit more narrow. So that's why it's going to be choice 2. All right, number 18. Andy has $310 in his account. Each week, he withdraws $30 for his expenses. Which expression could be used if he wanted to find how much money he had left after 8 weeks? Okay, the first thing that I want to do is I want to think about logically for a second. If he has $310 in his account, he's subtracting $30 in 8 weeks. So let's figure out how much money he has after 8 weeks. $310 minus a $30 withdrawal for 8 weeks. He should have $70 left in his bank account. So if you plug in the number 8, if you want to plug in the number 8, which one would result in the number 70? Or better yet, if you want to actually put in week 1, in week 1 he has $30 less than 310, so that's going to be $280. You can plug in anything that you want. So if you plug in w equals 0, he has $310 in his account. That's his initial investment into the account. When you have week 1, he has $280. At week 8, he has, as I just said, $70. So you could do anything you want, You just have to figure out, well, which one works. Well, if you take 0 and you plug this in, right, you get 310 minus 8 times 0. Well, anything times 0 is 0, so you get 310. So that works so far. Let's try 1, though. If you take 1, right, plug it in. 310 minus 8 times 1. That is equal to 310 minus 8. 8 times 1 is just 8. 310 minus 8, that's $302. No, after 1 week, he should have $280. That makes no sense. So choice 1's out. Let's take a look at choice 2. Plug in 0. If you take 0 and you plug it in, you get 0 minus 1, that's negative 1. So you get 280 plus 30 times negative 1. Well, negative 1 times 30 is a negative 30. 280 minus 30, that is equal to 250. So that makes no sense because that is way below what he has. Over here, we get 310 times 0. Let's plug in 0. 310 times 0, that's 0. Minus 30, he has negative $30. Makes no sense. The answer is choice 4. If you plug in 0, let's see, we get 280 minus 30 times 0 minus 1. Well, 0 minus 1 is negative 1. 280 minus 30 times negative 1. Well, negative 1 times negative 30 is a positive 30. So 280 plus 30, that is equal to $310. Let's make sure. Let's plug in week 1. When you plug in week 1, 1 minus 1 is 0. 0 times negative 30 is 0. With the 280 left over, in week 1, he does have $280. So your answer is definitely going to be choice 4. All right, number 19. The daily cost of production in a factory is calculated using C of x equals 200 plus 16x, where x is the number of complete products manufactured. Which set of numbers best defines the domain of C of x? So they're talking about complete products manufactured. They could be talking about iPhones, you know. So which is the best set of numbers that defines the domain? The domain is the products. All right, the products. You can't have negative products. Integers could be negative, so you can't have any negative products. Real numbers could be decimals. Well, you can't have complete products as decimals. That makes no sense. Positive rational numbers. Again, rational numbers could be decimals or fractions. That can't work. It has to be whole numbers. Whole numbers could be going from the number 1 all the way up to infinity. So like 1, 2, 3, 4, blah, 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 blah. Those are complete products that are manufactured. All right, so that's going to be choice 4. Number 20. Noah conducted a survey on sports participation. He created the following 2 dot plots to represent the number of students participating by age in soccer and basketball. Which statement about the given data is correct? Okay, so they actually wanted you to possibly put this into your calculator. But let's just go through the answer choices first just to see if there's anything that we could get rid of. The data for soccer players are skewed right. All right, well, soccer players. Skewed right means that there is a clear indication that the graph looks something like this. Actually, let me bold it. That there's a clear indication that the graph looks like a hump on the left. I know that it says skewed right, but remember, it's its opposite. Skewed right means that there's a giant hump on the left. That really doesn't show it. It kind of shows even distribution a little bit. So that can't be the answer. That's not correct. The data for soccer players have less spread than the data for basketball players. We'll talk about that in a second. The data for basketball players has the same median as the data for soccer players. All right, well, I can't really determine the median just by looking at this or this. I mean, I could assume for soccer players it's around like 9-ish because it does look evenly distributed. But this, I don't know what the median is. And then the data for basketball players have a greater mean than the data for soccer. Okay, so clearly we need to figure out these 3 choices by plugging this in. Now, this is what we are going to do. I am going to go to my calculator. This is how we do it. We're going to go to our calculator, and I'm going to type up a list and spreadsheet. So go to your list and spreadsheets, and I'm going to type in soccer player ages. And over here, I'm going to do basketball player ages. Okay. Oops. Age. Okay. So Oh, my apologies. I have to move this over. Shoot. I'm going to move it over to column C. And the reason why is this. This is showing the ages and the frequency. So what I'm going to say in my calculator is I'm going to say soccer player ages, and then I'm going to say the freq, F-R-E-Q, frequency of soccer. Over in the D column, I'm going to say BB, basketball frequency. Okay. So for soccer, the ages are 6, 7, 8, 9, 10, 11, 12. Now that I'm thinking about it, I didn't have to set up a basketball frequency column. I really didn't have to. But I'll do it anyway. It doesn't matter to me. All right, so for soccer players, there are 3 people who are age 6, and you could count those dots. So there are 3 people who are age 6, 4 people who are age 7, 2 people who are age 8, 2, 3, 2, 2. Now the basketball ages. So it goes 6, 7, 8, 9, 10, 11, 12. And for the basketball frequency, that is going to be 1, 1, 2, 3, 3, 4, 4. Okay. So now what I'm going to do is I'm going to go to my calculator. So do Control Doc, add a calculator page. Go to Menu, go down to Statistics, go to Stat Calculations, and then we're doing one variable statistics. The only variable that we're measuring here is our ages. So click on OK. I'm going to use my soccer players first. So I'm going to say soccer player ages, and my frequency list is frequency of soccer players. Click OK. And it comes up as this spread. So the only numbers that I need are my mean and my median. They're not asking you for the minimum, the quartile 1, the quartile 3, or the maximum. They're not asking you about that. They're asking you about the mean and the median. Now I'm going to do the same thing for basketball players. Do Menu, Statistics, Stat Calculations, one variable. Click OK. Your X list is the basketball player ages. Your frequency list is your basketball frequency. And you click OK. And again, your mean is what we're looking at, as well as the median, which is down here. Okay? So I'm going to write this information down. I'm going to write down this information right here. The mean for the soccer players is, let's see, the mean for soccer players is 8.6. 8.6. And the median for the soccer players is going to be, it looks like 8.5 is the median. Okay? Now your mean for the basketball players, that is, let's see, the mean of, what does it look like? 9.9. Okay? 9.9. And your median is equal to 10. Okay. So now we could take a look at choices 2, 3, and 4. All right. The data for soccer players has a less spread than data for the basketball players. Okay, spread means how evenly is it distributed? How spread out is the data? Is it spread across a broad spectrum? Yeah. This basketball player ages, this is skewed to the left. This looks like a normal distribution. So choice 2 is actually incorrect because it has more of a spread. Choice 3, the data of basketball players has the same median as the data. No, it doesn't have the same median. Median is 8.5 for soccer. Median is 10 for basketball players. The data for basketball players has a greater mean than the data of soccer players. Yes, the mean is 9.9 for basketball players. The mean for soccer players is 8.6. So your answer clearly is going to be choice 4. Okay, that one was a little bit more in-depth. Number 21. The graph of average resting heart rates is shown below. The average resting heart rate for adults is 72 beats per minute, but doctors consider resting heart rates from 60 to 100 beats per minute within normal range. Which statement about average resulting heart rate is not supported by the graph? Okay, let's take a look at choice 1. Not supported. A 10-year-old has the same average resting heart rate as a 20-year-old. Well, at 10 years old, you have an average resting heart rate of about 92 beats per minute. When you're 20 years old, you have a resting heart rate of 72 beats per minute. Well, they're asking for not supported by the graph. They're saying that it has the same average resting heart rate. No, your answer is choice 1. That's not correct. Now, I am going to talk about one of the answer choices, and I want to indicate it. Okay, look at choice 3. Some of you might have been confused by choice 3. It says here, watch this. A 40-year-old may have the same average resting heart rate for 10 years. If you read it too fast, you might have read it as a 40-year-old may have the same average resting heart rate for a 10-year-old. And you could have chose that answer if you read it too quickly. Don't ever go fast on the Regents. But if you read it incorrectly, then you got it wrong. Because at 40 years, his or her average resting heart rate is 72. And it continues on for 10 years. At age 50, that person still has an average resting heart rate of 72 beats per minute. So that is actually correct. Choices 2 and 4 are also correct. So the answer is going to be choice 1. But if you were confused on choice 3, that might be a reason why. All right, moving on. Number 22. The method of completing the square was used to solve the equation of this here. Which equation is a correct step when using this method? So the first thing that you have to do is you need to divide everything by the number 2 because there is a GCF. So you need to divide everything by the number 2. All right, divide by 2, divide by 2, divide by 2. So we get x squared minus 6x plus 3 equals 0. We're now going to subtract the 3 on both sides. We get x squared minus 6x plus something equals negative 3 plus something. In order to fill in this blank, we need to take half of the middle term and square it. So we take negative 6 divided by 2 and we square it. That will give us a value of 9. 9 and 9. So now we factor this. Well, what adds to negative 6 and multiplies to give you positive 9? That is just going to be x minus 3. X minus 3 is equal to 9, 8, 7, 6. Now we could continue to solve this by saying, well, this is x minus 3 squared equals 6. And that, ladies and gentlemen, is a correct step in the procedure, and that is going to be choice 1. All right, and that is how you do that question. All right, that's choice 1. All right, 23 and 24. Last couple questions. Here we go. Nancy works for a company that offers 2 types of savings plans. Plan A is represented by the graph below. So Plan A is represented by a linear model. Just keep this in the back of your head. Plan B is represented by the function f of x is equal to 0.01 plus 0.05x squared, where x is the number of weeks. Nancy wants to have the highest possible savings after a year. Nancy picks Plan B. Her decision is what? Correct or incorrect? So what you need to understand is, and what made this question difficult, if you are not, aware of real world applications, in a year, there are 52 weeks. They don't tell you that on the Regents, and they don't tell you on the reference sheet. It's just, you as a human being should understand that there are 52 weeks in a year. Okay? So we are looking right here, 52 weeks. Okay? Now, all we need to do is we need to, A, look at the graph of this, and at 52 weeks, it looks like that this savings plan is about $105. So what I'm going to say in my reasoning, I'm going to say that this is g of x. Do you know what? I'm going to call this, since this is f of x, I'm going to call this g of x. Well, g of 52, when you plug in 52, that's approximately equal to $105. Okay? When you plug in 52 for f, that gives you 0.01 plus 0.05 times 52 squared. Well, let's take a look. 0.01 plus 0.05 times 52 squared. That gives you 135.21. So it's about 135.21. Okay? So clearly f of x is greater than g of x. And this is Plan B. This is Plan B is represented by f of x. So her decision is correct, because Plan B is a quadratic function that will increase at a faster rate. That's going to be choice 2. This is a quadratic. A quadratic has an x squared term. So that defines a quadratic. Exponential, no. That means that x has to be in the exponent. So choice 1 is incorrect, and choices 3 and 4 are incorrect, because that means that Plan A is a better choice, which makes absolutely no sense. All right, final question of the video, number 24. In 2004, the 2014 winner of the Boston Marathon runs as many as 120 miles per week. During the last few weeks of his training for an event, his mileage can be modeled by M of W equals 120 times 0.90 raised to the W minus 1, where W represents the number of weeks since the training began. Which statement is true about the model M of W? Well, first and foremost, let's talk about this for a second. Make sure that you know this formula. I can't emphasize this enough. It appears every single year on the Regents and every single test. A of t is equal to the principal times 1 plus or minus a rate raised to the t power. Look at this number in here. That's 0.90. That means that this is going to be a decay function. Okay? Well, by what percentage? Well, since it's decaying, it's going to be 1 minus r is equal to 0.90. We're going to find the rate of decrease. Subtract the 1 on both sides. We get negative r is equal to negative 0.1. Divide by negative 1 on both sides, and your rate of decrease is 0.10, or that's the same thing as saying 10%. Okay? It's decreasing by 10%. So if you look at our answer choices, the number of miles he runs will increase by 90% each week. No, this is a decay function. This number is less than the number 1. Choice 2 is saying that the number of miles he runs will be 10% of the previous week. No, that makes no sense. The number of miles he runs, 10% of the previous week, that means that it is a decrease of, like, for example, if he were to do, like, run 120 miles and he said, all right, 10% of the next week, that means he only ran 12 miles? No. It should be 90% of the previous week. So that's incorrect. Choice 3 is saying M of W represents the total mileage run in a given week. Yeah. M of W, it says right here. During the last few weeks, his mileage can be modeled by M of W. And yes, that is the total mileage in a given week. That's going to be choice 3. That's absolutely true. Choice 4 is saying W represents the number of weeks left until his marathon. That makes absolutely no sense. No sense whatsoever. Because we don't know how many weeks he's running. So that's it. All right, so that's going to be choice 3. All right, that's the conclusion of this video. I hope that it helped. Make sure that you hit that subscribe button down below and visit my website at www.nysmathregentsprep.com for more math content in Algebra 1 and other mathematical subjects, and I will see you soon.